Hello, everyone, and thank you for joining us today on this live stream. My name is Hassam Mohsina, and I'm the program manager for the Microsoft Reactor in the Middle East and Africa. The Microsoft Reactors are hubs for founders and developers to meet, learn, and connect with developers, with the ecosystem experts, and learn about all what's happening in technology. And today, we continue a series that we have launched with MIA MVPs, where we are talking on the second session more about Azure Kubernetes services. And we are happy to have Mohammed Arousan joining us to continue this learning journey. As I mentioned before, this is a live stream, so you can interact with us in the chat, and we like to remind you that we follow this simple code of conduct. Basically, we're all here to learn, so let's keep the comment positive and related to today's session, and we will be addressing them shortly. And everything that we are doing here is recorded, and I will post also links during the session today to the past session if you want to rewatch it after the session, or also to the series page where you can register and not miss any of the future ones. Mohammed, thank you so much for doing this with us.
Thank you.
We're excited to have you here today and to continue this learning journey. So let us know, what are we expected to learn today?
Yeah, of course. Thanks, Hassam. And good afternoon, everyone. And thanks for being here today. So as you're aware, this session is the second session in our series. In the first session, we talked about Terraform and how to use Terraform to deploy and manage Azure resources. And in this session, we'll talk about Azure Kubernetes Service and how to use it to deploy and manage containerized application. And in the last session, we will use DevOps, Azure DevOps, to deploy AKS using Terraform. And we're going to have, let's say, a long demo on the last sessions in the series. So let's start. So today I will present what is AKS and the best practices on how to deploy and manage AKS. Before we start, just to remind you that you can post your questions in the QA area, and I will answer them either during the presentation or at the end of it. Okay, before we start, let me introduce myself. I am Mohammed Arousan. I'm Senior Cloud Consultant based at Netherlands, and I am Microsoft MVP in Azure with more than 9 years of experience. I worked in several projects for different enterprise customers across different regions and countries. I'm also holding several certificates for Azure and DevOps, including CKA and CKAD from Kubernetes. So feel free to connect with me for further questions or comments, and make sure to check my blog, azureheroes.com, where you can find many articles and codes regarding AKS. So in the next few minutes, we will break down some of the essential of what you need to know to plan and utilize AKS in Azure. We're going to have a short introduction on how Kubernetes came to the picture. We will talk about containers, and we will have a short comparison between containers and virtual machines. Then we'll jump to Kubernetes. We'll explain the components of Kubernetes, the services that Kubernetes offers, how to deploy and manage resources on Kubernetes using the manifest file. And in the next section of this presentation, we'll talk about Azure Kubernetes Service, why AKS, the benefits, the components, and how to manage AKS. And at the end, we're going to have a short demo if we have a time. Otherwise, we'll cover the demo in the last session in the series. So this slide shows a bit of history on how corporate used to run software components since 80s until they reach to Kubernetes. So starting at 80s to 90s, we used to run software or services in general, components on individual servers. So here you buy a set of servers, you have database server, web server, domain server, mail server, and so on. And if you want to achieve the high availability, again, you have to buy more physical servers and to connect with these servers to achieve high availability. And you can imagine how much the cost. And this was due to the compatibility difficulties and development environment specification. Then, beginning of 2000, individual servers were migrated to hypervisors images. Where's the bin? Yeah. So we start migrating or moving this physical server to virtual machines on a hypervisor, either Hyper-V hypervisor or Citrix or VMware hypervisors. And this helped in reduce the cost and improve the performance for all the servers. Then at 2010, microservices came to the picture and were later referred to as containers, which we will cover in the next slide. This emerged the need to create orchestration methods to manage underlying infrastructure, including networking, storage, access, etc. And currently, Kubernetes is there to help deploying, managing, scaling containerized applications. So it's important to distinguish between two concepts, containers and virtual machines. So VM created and managed by hypervisor, such as Hyper-V, VMware, Citrix, as I mentioned before, and these machines are running on host OS. That could be the same OS, but it requires a separate OS. Here you have the hypervisor, which it can be, for example, 2016 Windows Server. And this VM, each VM has a separate OS. While in containers is a standard package of software that bundle an application code. You have your application code together with the related config files and libraries with all the dependencies required to run your application. So here we don't have the OS is shared between across the containers. And it's not mandatory to have a Docker runtime, you just need container runtime. So Docker is a container runtime, so it's not mandatory always to have Docker. There are many alternatives nowadays. And to manage containers, you need to have a container management mechanism, which is the automation of deploying, updating, removing, scaling with a little or no downtime. So far we discussed the containers, VMs, and how we reach Kubernetes. So Kubernetes is an open source container orchestration framework, which was originally developed by Google. And the main aim of Kubernetes is to manage containers, be Docker containers or from any other technology, which basically means that Kubernetes helps you to manage applications that are made of hundreds or thousands of containers. And it helps you to manage them in a different environment, like physical machines, virtual machine, cloud, hybrid, and so on. So containers are excellent way to bundle and run applications. But running them in a production introduce several challenges, which include handling the failover, scaling for the bots or the nodes, service discovery, the security of the containers, and such complex and diverse challenges often need a fit-for-purpose solutions. Kubernetes is that solution. It offers different features to handle this, such as standardized APIs, self-healing. If the bot died, just replace it or create a new bot. Scalability, you can add as much node as you want. You can configure virtual scalability for your bots. Extensibility as well. So Like Hyper-V cluster or VMware cluster, Kubernetes is a cluster-based orchestrator. Consists of one or more master node that's connected to several worker nodes. Hence, we have two types of node in Kubernetes. The master node, which is responsible of managing the scheduling of containers onto the worker node, monitoring the health of the worker nodes, and orchestrating the deployment and the scaling of your applications. While the worker node is responsible only for running a set of containers or your workload. So your workload will be run on the worker node. And each worker node has several containers with different applications deployed on it. And depending on how the workload is distributed, we might have different number of containers on the worker node. So on the master node, we have mainly four components or four Kubernetes components. And on the worker nodes, we have two components. The first one is the API server, master node. So the API server, as you can see, it's the entry point. So it's the entry point to your Kubernetes cluster, which all Kubernetes clients will talk to, like the user interface, the CLI, the dashboard will use the API to connect with your Kubernetes cluster. The second one for today is the controller manager. Controller manager is keep overview or track on what's happening on your Kubernetes cluster. For example, if you have one bot and this bot died or need to be restarted, this will be managed by controller manager. While the scheduler is responsible for scheduling the container on different nodes based on the resource availability. So, for example, bot died. Here you have one bot died. Control manager will be notified, and it will ask the scheduler where to deploy it. Since the scheduler has all the resource availability records, it will reply back to the controller manager, yes, go and deploy it on the node 2, for example. So this is the primary use of the scheduler. The last one is the etcd. etcd, or the database, or the key value storage. It's responsible to store the current state of Kubernetes cluster. Hence, it has a configuration data inside and the status of each containers, nodes, services inside Kubernetes. While in the worker node, we have two components, kubelet and kubeproxy or service proxy. Kubelet is actually a Kubernetes process that makes possible for the cluster to talk to each other, to communicate to each other, and actually execute some tasks or commands on these nodes. Kubeproxy, it will maintain network rules on the node, load balancing, allow network communication in your bots from inside or outside your cluster. Also, we have container runtime, but I did not add it to the image because it's, let's say, a tool, or it's not a Kubernetes components anymore. So one of the ways to deploy resources into your Kubernetes cluster is through creating a manifest file. So as you can see from the code snippet, we have one deployment, the type deployment, with 3 replicas to create application with this image in GNX. So this is the application in GNX. So this file, or the manifest file, describes the workload in a YAML format, this YAML format. And it contains all of the needed information to create and manage described workload. And the structure of the file is vary or different, depends on the type of resources that you're going to create. So here, for the deployment, it has this structure. For other resources, the structure will be different. So we have many Kubernetes services, which we'll cover during our presentation. I have selected 8 of them, which they are widely used. Start with the first one, which is the bot. So what is the bot? Bot are the smallest unit that can be deployed in your Kubernetes, and it consists of one or more containers. And when containers or bot dies, a new one will create. So each bot has a private IP address or a routable IP address. So if you have one bot with 2 containers, in this case, you will receive only one IP address. So regardless how many containers inside your bots, you will be always receive one private IP address. And always the best practice in corporate is to use one container in each bot. Okay, to clear the ambiguity between images, containers, and bots, let's have a look at this figure. So imagine that your development team is creating an application called Reactor. So the developer they develop the code, for example, the front end, PHP, or anything. Then they will create something called Docker file. Docker file is just a set of instructions on how the image or the image will look like, or on how to build the image. We have here the base image, which is Ubuntu. Then you will start copy the code, etc. And once you build this image or the Docker file, you will have something called Docker image, or in general image. It's not mandatory to call it Docker. So you will have something called image. And when you run the image, you will have something called Docker container. So in the offline mode, you call it image, and when you run it, when you execute it, you will have the containers. So this is the image, and this is the container. So what about the bot? Actually, in general, or when we talk about Azure Kubernetes Service, there are an extra step which you need to do is by pushing the image from Docker image to Azure Container Registry. So Azure Container Registry is a private registry or to store the images, or Docker images, or in general the images. So once we store the image in Azure Container Registry, we'll create the manifest file, as you can see here, and here I point to the image. And once I run this on the cluster, I will have something called bot. So my application, my code, I have it now inside my bot. Okay. So another services Kubernetes offers is deployment, where you can use it to deploy a set of pods running same application to ensure that your application run continuously, allow easy update or scaling, roll back, update, or scaling up and down as needed. We'll show you an example. As we can see here from this manifest file, we have one deployment with 4 replicas. Here, I just changed the number to 6, and here we have 2 pods created, and we scale it back to 4 pods, and again we have now 4 pods. So this is the main purpose of deployment, to create set of pods. Okay, even before the cloud, no one likes deployment downtime. So everyone is aiming for their application to always be available to all the users. So 2 important deployment strategies that you should know. The first one is the Canary and the blue-green deployment. So in Canary deployment, here you have your application deployed, up and running, it's live, version 34. Your development team, they have a new release, which is 35. You will deploy the version 35, as you can see here. And since you have a load balancer, is responsible to distribute the traffic across your application or bots. Now you will configure the load balancer to send 10% of the traffic to the new application, and you will keep 90% of the traffic pointing to the old applications. And if no one complains, no issues, you keep increasing the number. Here you have 33 and 66. You keep increase the number until you reach 200% of the traffic to the new application. In case of any issue, you just roll back to the old version of the application. While in blue-green deployment, as you can see, you have the old application, old release of the application. You have the load balancer pointing to the old application. You deploy the new application. Then you do a cutover migration. Means the load balancer will suddenly point to the new deployed application. And here the developer actually, they realize that they're gonna do a lot of tests on the new release. So this is they think that they are sure that the deployment will go without any issue. And if in case any issue or any problem on the deployment, they can easily roll back to the old version. So these kind of deployment strategies are widely used in corporates. Some of them they like Canaries, other they like blue-green deployments. Okay, before continuing in the Kubernetes services, we should mention an important concept, which is load balancer. So load balancers are generally grouped into two categories. Layer 4 load balancer operate on transport layer, and we have layer 7 on OSI model. So what's the difference between layer 4 and layer 7 load balancers? So layer 4 load balancers focus on delivering message based on their transport layer protocol, TCP, UDP, without looking at the message content. While layer 7 load balancer focus on delivering message based on their application protocol like HTTP, HTTPS, and the actual content of each message. So they are able to understand the message and make more intelligent routing decisions based on the content. So the content will be scanned in layer 7. And there are some of the routing mechanisms used in the load balancer, such as round robin, which is the best one. Send one time to this node, another time send it to this node. We have weighted round robin, least connection, least response time. So after deploying your application, the next step is to provide network connectivity to your pods. And for this, we use another service from Kubernetes called services. So Kubernetes use services to logically group a set of pods together and provide network connectivity. So in service, the traffic will come from inside your cluster to the service IP, and the service IP will distribute the traffic across your pods. And there are 4 types of services. The first one is the node port, where your deployment will have an external access, or they will be externally accessible. But one point that you should consider that you can only use ports from this range, 30,000 to 32,000 something. In a cluster IP, you will not have external access, or your application will not be externally accessible. On load balancer, which is the widely used, your application will be externally accessible outside your cluster. It means outside your machines. Let's see an example. This whiteboard. So cluster IP, as we said, your deployment or application is accessible inside only your cluster. So this is your cluster, VM1, VM2, VM3, etc. And the application will be only accessible inside them. Node ports, see the traffic will come from external. It will go to the node because here you have an port exposed or open on the node, like 31,000. And the port is open in each node. So when you scale, when you add more nodes, you have to expose, or automatically the port will be opened in each node. So the traffic will come to from external to the node, and from node it will be sent to the service, and from the service to boot or to your application. In external on load balancer, the traffic will come from external load balancer to the service, from service to your bots or applications. Okay. So another service is Ingress, which used to expose Kubernetes services to the world. As we can see, the traffic in Ingress will come from internet, my Reactor, my app, reactor.com. It will go to Ingress controller, from Ingress controller to the service, from service to your bots or deployment. And as you can see here, we have one Ingress and multiple service. So Ingress, as we said before, it's smart. It can understand the message content or the URL, etc. So based on the rules, it will send the traffic to a specific service, to this service or to different service. So you need only one Ingress to handle all the traffic inside your Kubernetes cluster. You don't need to have like 100 Ingress, only one. So Ingress is probably the most powerful way to expose your services, but can also be the most complicated. And there are many types of Ingress controller. We have from Google Cloud Load Balancer, from Nginx, Contour, Istio, Agix from Microsoft, and so on. Another service we have today is a ConfigMap. ConfigMap is used to send the value to pass variables of configuration to your bots instead of putting them as a static code in your application. It actually is similar to the config file in your web deployment or in your web application. So instead of just putting them as a static, you can just use ConfigMap in Kubernetes to send this data or variables to your bot. In our case, we have database, MongoDB, we have the database URL, we have the keys. So we mount this data as a volume on the bot. And once the bot is started, it will read all of this configuration. So this configuration is available for the bot when it starts. Secrets similar to the config map, but actually it's used to pass a secret or confidential data like passwords, token, key to your bot. And it's encrypted and it's stored in the etcd value. But when we talk about in corporate, actually they go with key vault or with HashiCorp Vault and so on. So they don't use it actually in real cases, but it's worth to mention. We have also DaemonSet service in Kubernetes. DaemonSet it has a primary goal which is to make sure that each node in your Kubernetes cluster, the worker node, has one bot deployed. So you have three nodes. DaemonSet will make sure that each node has one bot deployed. And in the future, if you add more nodes, DaemonSet will create this bot, or it will add the bot, the new node. There are a few use cases actually for DaemonSet. Last service for today is StatefulSet. So in general, bots are non-persistent. So once it's deleted, the contained data will be deleted too. So StatefulSet came to solve this issue. So it guarantees the ordering and uniqueness of different bots. So we have, and especially it's used for database and message queues and so on. Because in general, bots, once you have the bots, once it dies, the data will be deleted. While in database, I cannot delete the data because I need the data in that, for example, in MongoDB or even in MySQL database. So StatefulSet will create one master bot and, for example, 3 slaves bot. One of the cases, if one bot died, StatefulSet, or in general Kubernetes, will create a new bot. And this bot will use the same private volume or persistent volume from the died bot. So bot died, keep the persistent volume and assign it for the new bot. This is how it works. But to be honest, due to the complexity managing StatefulSet, I have seen almost all the corporates using database as a service. So they prefer to go with the database as a service instead of managing the StatefulSet. Okay, so in the previous section, we covered Kubernetes in general, and we talked about some Kubernetes services. In this section, we'll speak about AKS, Azure Kubernetes Service. So since deploying and maintaining Kubernetes cluster is still not an easy task, like any other clusters, Hyper-V or VMware clusters, Microsoft Azure Kubernetes Service helps engineers to manage Kubernetes cluster. So we said before, we have a master node and worker node. So Microsoft, they call the master node a control plane. And control plane or the master node with all the components will be managed by Microsoft. So you don't need to worry about anything here. While you should only manage your worker node. It's managed by you. So the API, database, etc. managed by Microsoft. So actually this results in many benefits, such as scalability. As you're aware, Azure virtual machine or Azure in general is scalable. So you can add as much VMs as you want to your clusters or to your deployment. You don't need to worry about the master node or the backend hardware, etc. It's not managed by you since you are in the cloud or even with Microsoft. Also, it reduces the initial setup time. You can create your Kubernetes cluster in Azure in just a few minutes. You just focus in your AKS deployment or in your application. So as usual, Microsoft provided best practices guidelines to use AKS. These are some of the best practices from this ebook, which I'm gonna share with you right now. Hassam, if you can just share it with them. Thanks. So I have write some of these best practices. For example, always use private cluster. So when you deploy your Kubernetes cluster, you will get an option to deploy private or public cluster. So it's recommended to use or to deploy a private cluster. use Azure CNI, which is very important. I will cover it in the next slide. Use RBAC, use Defender, and so on. You can find all the best practices and the recommendation on how to deploy and manage Kubernetes cluster inside this ebook. So, as we said before, Kubernetes is made of master node and worker node. Master node managed by Microsoft, or Microsoft, they call it a control plane, and worker node is managed by you. I'll show you an example. Just a second. Yes. So here we have Kubernetes cluster or Azure Kubernetes cluster. So this resource group, we can call it like data plane. Click here on it, you'll see the Kubernetes cluster. If we go to, as you can see here, we can manage the cluster. If we go to properties, we have infrastructure resource group. If we click on it, this is what is managed by Microsoft, or we call it master or control plane. Load balancer managed by Microsoft, manage identities, VM scale set, and all of these are managed by Microsoft. This is when we say that master components managed by Microsoft, so you don't need to worry about them. Yes, they are exist in your subscription, but you don't need to manage them or to look at them at all. Okay. So AKS is a cluster based, as we said before. Master node is managed by Microsoft, but we have also in AKS two types of node pools. We have the system node pools and user node pools. And system node pools, the main purpose to host critical system pools like DNS, monitoring, metrics, and so on. While user node pools host your application. So critical or system pools will be in system, your workload will be in user. And since they are VM scale set, you can easily scale up, scale down these machines. So if we deployment, we have the user scale set, this is scale set. As you can see here, we go to the instances. We have one instance only here. So it's virtual machine scale set. The same for users. And if you go to the node pools, see, you can easily scale the node pool. You can upgrade, you can update the image from 1,000, as you can see. This is how you can play with the node pool since they are VM scale sets. So you can change the size, you can do whatever you want with your images. AKS Networking. Okay, so there are two plugins in AKS. The first one is KubeNet, the second one is Azure CNI. In KubeNet, the node only will receive a routable IP address, while the bot will receive IP address from logically different IP range. So only the node receive routable IP address, and the pod use NAT to communicate with other resources outside your AKS cluster. While in Azure CNI, both pod and nodes will receive a routable private IP address. So unlike Kubernetes, the traffic to endpoint in the same virtual network is not NATed to the node primary IP address. One of the differences also between them is that in Kubernetes, you can have up to 110. This is the soft limit, actually, pod in each node. While in Azure CNI, you can have up to 30. This is the soft limit. While the hard limit is 250 for both. 250 here, and it can be 250 here. And to calculate how many IPs you needed, especially for Azure CNI, since, as I said, Microsoft is recommended to go with Azure CNI, there is one equation from Microsoft for Azure CNI. So to calculate the subnet size, take the number of nodes that you have. For example, I have 2 nodes. So 2 plus 1, 2 plus 1, maximum number of pods. So we said the soft limit is 30, the hard limit 250. So I will go with 30. So 30 pods. Three plus 3 multiply by 30. Here. 93. If I'm not wrong. Okay. So what's the main difference between Azure CNI and Kubernetes? Just to make it clear for everyone, we'll draw. First one is okay. Here we have Kubernetes. So here you have Azure Virtual Network, VNet, and here you have your subnet. Here you have your VNet. Here you have your node. Inside the node you have pods, right? Node 1, node 2, node 3, and so on. So in Kubernetes, we said only the node will receive IP address, a routable IP address from the pod IP address. So what about the pods? We said that the pods will receive IP address from logically different address range. It means there is one address range inside here, inside the pods, or inside the VMs in the cluster. It will be like this. So this range, for example, if we're gonna say that the range for the VNet is 10.10.0/16. Okay. So the range of this IP address or for this subnet will be like, sorry, 10, for example, 244.0.0/16. So this is the range of this address range. There is no overlap totally from not from the subnet, totally isolated from the subnet. And the first node here will be 10.244.1 or let's say 0.0/24. Oh, sorry, for this pod. And for this pod will be .1 actually. For this pod 0.5, for example. For here, 10.244.1, for example, .2. So how are they going to communicate? Where's the netting? Where the netting is happened? Actually, Azure will deploy UDR. Why this UDR and why we need it? UDR will be used actually to send the traffic outside. So it will say the traffic going to this pod, this one, for example, one, it will be like this, actually. Traffic going to this range, to 244.0.0/24, send it to this IP, IP1. Which IP? The IP, this IP. And the traffic going to the second node, 10.244.1.0/24, send it to the second node, which is this node. While in Azure and CNI, Azure CNI, you have the VNet, you have your subnet, you have your virtual machines, the bots. From the subnet, the node will receive IP, the bot will receive IP from the subnet, and so on. So, routable, IPL, IP. So this is how, what's the main difference between Kubernetes and Azure CNI. So it's clear. So there are some features not supported in Kubernetes, such as Azure Network Policy, which is not supported in Kubernetes, but Calico Network Policies is supported, so you can use Kubernetes. Windows Node Boot is not supported with Kubernetes. Virtual Nodes add-on is not supported on Kubernetes. Okay, so similar to Kubernetes, AKS has same services. We said we have 3 or 4 types of services. The same, everything's the same except one thing. When we deploy the load balancer, or when we select a load balancer, Azure will create a load balancer for you. In this case, so you deploy a service, you select a load balancer as a kind of service. Azure will create Azure load balancer, so the traffic will send from inside, let's say, to AKS node, and from AKS node, it will go to your bots. So load balancer, we said this is layer 4. It's not smart. Doing round robin only. While the advanced one, we have something called Ingress. Ingress is layer 7. To expose your bots to the external world or to the world. And actually, there are 2 options available when we talk about Ingress. In Azure, you have 2 options. Azure to either to go with application gateway, or Microsoft they call it Edge, or to use or to go with Nginx control. So what's the main difference between them? I will show you an example. So here you have, for example, your virtual machines, your worker node, and here you have your bots. And you have the service, as you are aware. So Ingress is used, So Ingress is used to expose the service, as we mentioned before. So this is a service, as we see. Now, with Nginx controller, we create Nginx will create some bots here actually, and in front of them it will create a service. So, and outside Azure or outside your cluster, it will deploy a load balancer. So the traffic will come from Azure load balancer layer 4. It will go to the Nginx service. From the service, it will go to this pod. This pod is called Ingress controller. Ingress controller. It will do the advanced or the intelligent things inside the load balancer. So it will see the traffic is going where, if it needs to be SSL termination. All the smart thing will happen inside this pod. And since this pod is inside your cluster, it will be able to see all the service and it reach to any service inside your cluster. So here, all things, smart things happened. After that, it will go to the service. Just to change the color. So it will go to the service, and from service, the traffic will go to your pod. So again, Nginx controller will create load balancer, and there's one Ingress controller bot available in your cluster. While we have Azure, we call it Microsoft. You have your nodes, you have your bots, you have service between the bots. By the way, Kube proxy for the networking is responsible for such thing. So we have the service here on Azure or application gateway Ingress controller. We create only one bot here. Okay. So this bot has one main goal, one main purpose. And in front of that, Azure will create application gateway. The icon is like this. Yeah. Application gateway layer 7. Here it's layer 7. So the traffic, again, the traffic will come from internet to layer 7 application gateway, and from layer 7 it will go to your bot, not to the service. See how Microsoft they create this? So the traffic will send to your bot, not to the service. But why we need the service? It's used actually to tell the layer 7 or to tell the application gateway which bots belong to this service only. And this bot, the main purpose for this bot, only one in all the nodes. To translate actually the comment that you run it on kubectl or manifest file, it will translate it to Azure ARM, and it will execute it on Azure. So if you play with the Ingress, etc., this bot is responsible to detect these changes and create the changes on Azure. You modify things here. You don't need to go to layer 7 or load balancer to play with it. This bot is responsible to handle this part. So as we can see with Azure Kubernetes Service, you can easily, in minutes, you can create your cluster. You can start upgrading your cluster, scaling cluster in just one command. Also, AKS support and -2 stable minor release. It means 1.1.1. So this is the minor version, the number that you can see in the middle. And Kubernetes community release a minor version roughly every 3 months. So we'll cover this demo on the next session in our series. Thank you all. Any question? Encryption type for the secrets. I'll send it to you. Apply with the encryption type. EAS and SHA, I believe. Any question how to write multiple secrets in YAML? Multiple secrets? Yes, you can. I'll send it to you.
Thank you, Mohammed, for today's session and for addressing the questions that were in the chat. As also a reminder for everyone, we have this Reactor survey where you can send us feedback about today's session and also about the topics that you would love to see in the future. We appreciate the feedback, and you can use the event code that's written on the slide. It's 18992 at the start of the survey to refer to today's session. So one more reminder as well in the chat, I posted about a few things. One was the reference that Mohammed mentioned during the presentation on Azure Heroes, which you can check, as well as how you can continue the learning journey on Microsoft Learn. And we recommended one module for you to do. There will be also a follow on session next week to continue the series where we will get more practical. So make sure that you register for the entire series on the Reactor website. That was the first link I shared. That's the series page where we will continue to add more sessions with the MIA MVPs in the future. All right. Thank you again, Mohammed. It was a pleasure having you, and looking forward for our final session on this mini series also next week, where we will continue talking about Kubernetes and get more into the implementation and the practical work.
Thanks, Hassan. Thanks, everyone.
All right. Have a good day, everyone, and see you next week. Bye bye.